So we're starting with exponential functions today, and we'll see how it relates to logarithmic functions. And I'm just going to pick a select few that if we do them and understand them, you can do the rest on your own. Let's start with number 3. Okay. And again, please do this on a separate sheet of paper. So we've already looked at fractional exponents. And what we saw was that the numerator is the power, the denominator is the root. And so this is negative 25 to the power of 1, and it's the square root of that. So we can rewrite this as the square root. We usually don't write the index of 2 there, but I'll put that there, of negative 25. And then the power of 1 could either go on the inside or it could go on the outside. What's the answer going to be here? 5i. Okay. So square root of a negative is imaginary. That's where the I is coming from, that negative. And then the square root of 25 is 5. And we're done with 3. How does that compare with number 2? Let's go back and do number 2. Should we get the same answer? Why not? So they almost look the same except for the parentheses. The parentheses, here is saying that the negative also has the power of 1/2, where on number 2, the negative is not in parentheses, so that 1/2 power only belongs to the 25. So just be careful when you include that negative, when you don't. So that negative is just on the outside, and this would be the square root of 25 to the first power. So that would be negative 5 as an answer versus 5i. 1, 4, 5, and 6 are like that. Let's take a look now at number 9. Well, number 8. Let's do number 8. Again, we've done stuff like this before. What would you do to solve for number 8? Square is a cube root. Cube root is 64. And then the squared we could put underneath the cube root or outside. What would you rather do? I think it would be easier to have it out here. Because if we square the 64, you're going to get a lot larger number, and then taking the cube root of a larger number is going to be more work for you. It's easier to first take the cube root of 64 and then square your answer second. What's the cube root of 64? 4. 64 is 4 times 4 times 4. And so the cube root of 64 would be 4. And then we square that, and you get 16. Let's take a look at number 13. How do we do that one? No solution? No, there's a solution. Okay, notice on 13, the base is the same, and we're multiplying. What's the exponential rule? When the bases are the same and you're trying to multiply, you add your exponents. So this would be 7 to the 1/3 plus 5 over 3. And common denominator, so we can add that, and we get 7 to the 6 over 3 to 7 squared, which is 49. Let's look at 15. That's a division sign, okay? So we have 5 to the 7/3 divided by 5 to the negative 2/3 power. And when we're dividing, what do? If the base is the same, what do you do with the exponents when you're dividing? Subtract. So 7/3 minus the negative 2/3. And if it's already negative, you're going to have a double negative. So this would be 5 to the 7/3 minus the negative 2/3. And that reduces to 5 to the 3rd, which is 125. So just remembering some of the rules: when you're multiplying, you're adding the exponents. When you're dividing, you're subtracting your exponents. Look at 16. 2 to the 1/3, or the cube root of 2, times the square root of 3, all raised to the 6th power. So here we have multiplication problem. Can I multiply these together? They have different bases, they have different exponents, everything's not alike. So we can't, we're kind of stuck with what's in there. Is there anything we can do with this? What's that? We could get a common denominator, that's an option, which would put things into the same root. So I will follow, because that would work, and then I'm going to do the separate way. So there's two ways to do this. So one is to get a common denominator. What would be a common denominator? 6. So we can rewrite this as 2 to the 2 over 6 times 3 to the 3 over 6 raised to the 6th power. What would you do next, Atticus? Okay, so you can look at this as the 6th root of 2 squared times 3 cubed. So you can't multiply the 2 and the 3 together yet, but you can find 2 squared and 3 cubed and multiply that together. And that would be under, would still be the 6th root of that, or raised to the 6th power. And 2 squared is 4. 3 to the 3rd is 27. What happens when you raise the 6th power to a 6th root? Get rid of that. And then what's 4 times 27? 108. Okay, so that's one way. Maybe not the easiest way, but it works. What's another way? Megan, what were you pointing out? So we can distribute this to these exponents. And when you distribute, you're actually multiplying that 6 with the 1/3, multiplying the 6 with the 1/2. Make sure you're multiplying it with the exponents, not the base. And so we end up with 2 to the 6 over 3 times 3 to the 6 over 2. And that's 2 squared times 3 cubed, which is 4 times 27, which is 108. So both ways we get 108. Way on the right's easier. I didn't mind doing the way on the left because sometimes that will be the easier route. And so knowing both ways is going to be helpful. Let's skip now to 19. 19, we have a decimal. And if you have a decimal, I encourage you to get rid of the decimal. Change it to a fraction. So how would you change this decimal to a fraction? 1 over 1,000. So if you have 3 decimal places, you're going to put it over 1,000. If you have 2 decimal places, you'll put it over 100. If you got 1 decimal place, you'll put it over 10. Right? So this would be 1 over 1,000. And all of that is raised to the power of negative 2/3. What do you know about negative exponents? It's kind of a reciprocal part, right? So you can make this a positive 2/3 if you flip the fraction over. Make this 1,000 the positive 2/3. And then, well, that's our cube root of 1,000 squared. 1,000 is 10 times 10 times 10. So the cube root of 1,000 is 10. And 10 squared is 100. So if you have a decimal, change it to a fraction. Looking at 21 to 25, any requests of what you want to look at? Maybe not sure how to do if you encountered that one. 23? Okay. So any idea, guys, on 23? What's that? So you have an exponent of an exponent, so you're going to multiply them together. And when you do that, you have 4 times the square root of 3 times the square root of 3. What's the square root of 3 times the square root of 3? 3. And so that gives you x to the 12. I'm not going to do 22 with you, but I do want to ask, what do you think you're going to have to do on 22? You're going to have to simplify the square root of 12. And it'll be a little more helpful after you do that. Okay, so make sure you simplify that on 22. 24 and 25, I'll do one of those. Let's do 25. What do you think we're going to have to do on 25? Yeah, anybody know what this is called when they write fractions like this? 3 and 3/8? Mixed number, right? And last time you probably saw this was elementary school, maybe junior high, because they're not very helpful. And so if you have a mixed number, get it out of that, change it back into an improper form. So this is really 3 plus 3/8 is what it is. And you remember how to change it back? 3 times 8 plus 3. Do you know why they do that? Well, this means 3 plus 3/8. How do you get a common denominator? You multiply it by 8. So you multiply top and bottom by 8. And it says 3 times 8 plus 3. It's a shortcut for adding. That's where that's coming from. So you're going to get what? 27 over 8. So 27 over 8 raised to the 2/3 power. So take the cube root of 27 over 8 and then square that answer. God bless you. And 27 and 8 are both perfect cubes, so it's working out nice for us. What's the cube root of 27? And the cube root of 8. And when you square them, you end up with 9 over 4. Let's take a look at one of these at least. On 26 to 29, any requests? 28? Okay, let's look at 28. When you multiply, we got the same base. What do you do with the exponents? You add them. So what is x to the 2/3 times x to the negative 2/3? Which is? It's 1. Because so when I multiply these, I have x to the 2/3 plus negative 2/3. That's x to the 0, and anything to the power of 0 is 1. Okay, so that's the first product, plus x to the 2/3 times x to the 1/3. What's that going to be? X to the 3/3, which is x to the 1, which is x. I'm going to add the 2/3 and the 1/3. I get x to the 3/3. So when I multiply those together, I just get 1 plus x as an answer. Okay. You okay with that? Something like 30, I'm not going to do with you, but just talk through it maybe with you. What would you do here? If you have two different bases, you're just going to take the exponent and multiply it with the exponents, right? And then make sure you don't end up with a negative exponent as your answer, in your answer. What do you want to do, 32 or 33? I'm going to leave 34 for you. I know you choose that one if I choose. 33? Okay. So 33 question, can I take the 2 and multiply with the exponents? No. So you can only do that if you're working with one term. How many terms are here? 2 terms, remember, are separated by plus or minus signs, Diego. And if you have more than one term, don't take the shortcut. You cannot multiply exponents with exponents. You're going to have to multiply it. You're going to have to rewrite it as x to the 1/2 minus y to the 1/2 times another x to the 1/2 minus y to the 1/2, and then distribute. I'm going to pause here and give you a couple minutes to try to get that answer. After you multiply this out, you want to get x minus 2 times x to the 1/2 y to the 1/2 plus y. I would be okay with this. Here's another option. That is okay as well. Yeah. So right here. Are we looking at this line or this line? This first line? Okay. So the one above it. Okay. Why wouldn't it be what? Because when you're squaring something, that means you're taking the exact replica of itself. So they're not conjugates. So if I think you may be thinking of something like this. If I had x squared minus y squared, and I factored that, that would be x plus y times x minus y. That's true. But if we start with x minus y with a square on the outside, That's different. That's x minus y times another x minus y. You see the difference between the two? You were thinking this difference of two squares, where it's a difference, but the square's on the outside. Okay. Let's skip now to sketching graphs. Okay. So exponential functions in Math 1 or in Honors Math 8, whichever one you took, you looked at exponential functions. It's been a while, but do you remember what? Actually, we did it in our class last semester, or in Math 3. You saw it. Do you remember what exponential functions look like? So this shouldn't be too much of a leap for us. So this is review for us. What I want 3 points in your graph that you show me, and I'll demonstrate with you guys. But we have done this stuff. It's just been a while. So let's take a look first at number 35. So these 35, 36, 37 we'd call parent graphs. So it's same as 38. When we get to 39, that would not be a parent graph because it's been translated a little bit. God bless you. But on 35, all your parent graphs, remember, have a, God bless you again, have a horizontal asymptote, which means not going to touch the x-axis. So it's close to the x-axis, not going to touch it. And that's at y equals 0. And then you can just take some test points. So if I plug in 0 for x, what do we get for y? If I plug in 1 and plug in 2, and so I'm going to plot those points. And as it gets closer to the asymptote, it just follows that horizontal line there. And so I have 3 points. Label your points on your graph, the 3 points that you choose. So we have 2, 9 here, 1, 3, and 0, 1. We did stuff like 35, 36. We didn't start with stuff like 37, 38, where it's got a negative x. Do you remember what happens when the negative's in front of x in terms of transformations? It reflects over the y. So that's one way to think about it. The other way to think about this is to get rid of the negative. And that's probably the more natural way, something I would do. So number 37, I would rewrite this as y equals, this is 2 to the negative 1 to the power of x, right? Because negative 1 times x is negative x. And what's 2 to the negative 1? 1/2. So this is the same thing as y equals 1/2 to the power of x. And this is, I would tend to go this direction. And this is going to end up being a reflection of y equals 2 to the x across the y-axis. So it will be decreasing. So if you can imagine what we did on 35, if I rotated that around the y-axis, it would be decreasing instead of increasing. So it's still going to get closer and closer to the x-axis, but more on the right side of the graph instead of the left side. Still got that horizontal asymptote at y equals 0. The points that you're going to want to plot, though, are probably the points on the left side, because that will give you integer values. If you go on the right side, it's going to be lower than 1. They'll all be fractional. You can graph them if you want. It'll just be harder to find those points. So easiest point to plug in is 0 for x. What's 1/2 to the 0 power? 1. What's 1/2 to the negative first power? 2. And what's 1/2 to the negative second power? If you forget this, so let me show you the work here. So here's 1/2. If I raise that to the negative second power, that would be 2 to the positive second power. So you move the 2 to the top, and that gets rid of the negative exponent, and 2 to the second power would be your 4. So when I plug in a -2, I get a positive 4. So I'll plot those points. And so this is decreasing. And I don't think we've graphed any of these where they're decreasing. And then give me the 3 points that you graph. So -2, 4, -1, 1, and 2, and 0, 1. All right, so that's what your graphing is going to be like. And then the last part, they give you the left side equal to the right side. Some are true, some are false. And you got to decide if they're true or false and show why. So this will be like when we did the proofs and we started with the left side and showed that either the left side's equal to the right side or not equal. And I'll demonstrate with a few of these. So for example, number 40. What do you think, true or false? 2 to the x minus 1 is equal to 1/2 times 2 to the x. So here's what I do. I'd start with the left side. So 2 to the x minus 1 is equal to 2 to the -1 times 2 to the x. Is that true? Because when you multiply, you add the exponent. And 2 to the -1 is what? 1/2. So that's equal to 1/2 times 2 to the x. And so I just showed that the left side is equal to the right side, and so I'd say true. Just like a proof, but it's not as hard. Okay, but you got to get comfortable with the exponents. It's going to make you get a little more comfortable with them. I'll do a few of these, and doesn't just any requests. Look at them. Take a look. See if there's something that you're just not sure how you'd handle. Or maybe you feel good with all of them. Let me show you one that wouldn't work and show you how to show that it doesn't work, okay? So 42 is false. And so here's what you would do. If you start on the left side, you say, okay, well, 2 to the x squared is not going to be equal to 2 to the 2 times x. Okay. Because everything's the same. In general, x squared is not the same as 2x. Now, there are special cases where that will be true, like if x was 2, 2 squared is 2 times 2. But in general, you can't plug any x in. And like if a 1 squared is not 2 times 1. A 5 squared is not 2 times 5. So I could say that. And the reason I'm setting this up is because I know that 2 to the 2x is going to equal 2 to the x times 2. And so that 2 to the 2x is equal to 2 to the x times 2. And so here's one side, here's the other side, and the left side is not equal to the right side. So I showed that 2 to the x squared is not going to be 2 to the x squared. And so I'd say false. So just giving you a little example of how you can show that something's. Do you guys want me to go over any of the other ones for true or false? Okay. Then I'll let you work on the homework.